Welcome to the Explainer. Today, we're going to build a Python program completely from scratch. But we aren't just writing static code. We're actually going to evolve it. We're giving it a memory to store things, ears to listen to our inputs, and the stamina to just run on autopilot. I am so excited to guide you through this transformation. So, let's get building.
Here's our quick roadmap. First, we'll meet your memory with variables. Second, naming rules and data types. Third, talking to your program. Fourth, converting number inputs. And finally, repeating tasks with loops.
Let's dive right into Section 1. Meet your memory. Variables.
So think of a variable kind of like a labeled box in a giant warehouse. It's where your program safely stores data using an assignment operator, which, by the way, is just the simple equal sign. You see, instead of letting your information just vanish into the void the second a program runs, we use these variables to securely access and manipulate that data later on. Without them, well, your program would have severe amnesia.
Take a look at this. We're assigning the number 503 to the variable room. And once that link is made, it's locked in. Our program can effortlessly recall that exact value right from memory and print it out for us. It says, I am staying in room number 503.
Now remember, they're called variables because they can, well, vary. They change. Notice how this variable initially points to 2.75, but just a few lines down, we assign 99.95 to that exact same variable name. When we do that, the old data is completely wiped out and the program effortlessly outputs the new, much richer value of 99.95.
Moving right along to Section 2, naming rules and data types.
Okay, so to make these memory boxes work, you absolutely must follow some specific naming rules. For instance, no spaces allowed, and definitely stay away from Python keywords. Plus, your variable name has to start with either a letter or an underscore. And hey, this next one is huge. Python is entirely case-sensitive. That means uppercase and lowercase characters are treated as totally different things. Also, always choose a descriptive name, something like temperature. Seriously, do yourself a massive favor and don't name your variables random things like x or data123. I promise your future self will thank you for it.
Now, when you're storing numbers, Python is pretty strict. It categorizes them either as an int for whole numbers or a float for decimals. And this actually dictates exactly how your math operations are going to behave. Basically, a numeric literal written without a decimal, like 7 or -9, is an int. But the second it has a decimal point, boom, it's categorized as a float. You really need to keep this in mind because you'd use an int to, say, count the exact number of people in a room, but you'd absolutely need a float if you were calculating their money.
But what if we're not dealing with numbers? Well, beyond math, Python uses the str, or string data type, whenever you need your memory boxes to hold text. Whether we're talking about a user's password, a physical mailing address, or literally just a random sentence, strings are your absolute go-to data type for storing any kind of characters.
The really crucial takeaway here is that a single variable can refer to items of any type. As you can see, you can seamlessly mix integers, floats, and strings right there in your code. We've got one value acting as an int with a number 99, another as a float holding 45.9, and yet another holding the string ABC. It's pretty cool. A single Python script can effortlessly juggle all of these distinct data types in memory simultaneously. Let's jump into Section 3, talking to your program.
All right, so our program has a brain, but now let's give it ears. We're going to use the built-in input function so it can actually listen to us. When this input function runs, it throws up a prompt for the user and then literally pauses the entire program until they type something. It just waits for the user to hit that enter key, and once they do, whatever data they typed at the keyboard is captured and securely returned directly back into our program.
You can see it perfectly in action here. This interactive greeting program steps through that exact process. It pauses to listen for a first name, then a last name. Once it captures the keyboard inputs, in this case, Vinny and Brown, it instantly grabs those fresh new memory variables and spits out a custom greeting. Hello, Vinny Brown.
Moving on to Section 4, converting number inputs.
Now, here is the catch. The input function always returns the user's input as a text string. That means even if someone types their age as a number, the computer just sees it as a word. So if a user types 25, the program isn't storing the mathematical value of 25. It's storing the text characters 2 and 5. And since math operations can only be performed on actual numeric values, this creates a massive roadblock for things like calculators or any kind of data processing. Honestly, if we can't do math on these numbers, our program is totally stuck.
But don't worry, there's a fix. To overcome this limitation, we use two absolutely vital conversion functions, int and float. Think of them like a funnel. They translate those text strings back into true, mathematically usable numbers. You simply pass your string argument right into the parentheses. The int function hands you back a solid whole integer, and the float function hands you back a real number complete with its decimal point.
If we look at this code snippet, we can actively see those int and float functions wrapping right around our input prompts. It's so seamless. They snatch the user's raw text, instantly convert Chris's age into a mathematically usable integer of 25, and turn his income into a precise float of 75,000.0. Boom, ready for our database.
All right, final stretch, Section 5, repeating tasks with loops.
Let's give our program some serious stamina. You see, real programmers avoid manually writing the exact same code over and over again by using loops. Instead of duplicating statements endlessly, you just trap your code inside a repetition structure. In Python, you generally deal with two types: a condition-controlled loop using the while statement, which runs based on a true or false evaluation, and a count-controlled loop using the for statement, which just runs a specific, predetermined number of times.
Today, we're going to focus in on the condition-controlled while loop. Just look at the logic path in this flowchart. It's so clean. While a condition remains true, the task repeats. It flows down into the statement block, does its thing, and loops right back to the top. It just keeps spinning and spinning until that condition finally evaluates to false. Only then does it break out and escape the loop.
And here it is, our fully evolved program. It brings together everything we've talked about. First, it sets a control variable. Then it checks the true or false condition, captures our converted number inputs, calculates a sales commission, and finally, asks the user if it should repeat the whole process. See how we set keep_going to yay. Our while loop then checks, hey, does keep_going equal yay? It does, so it runs the math. Then at the very end of the loop, our input function politely asks the user if they want to calculate another commission, giving them the ultimate power to feed the loop all over again.
Honestly, just look at the stamina of this output. Our program tirelessly calculates commissions, $1,000, then $3,000, then $1,200, just totally on autopilot. It only stops when the user finally types N. That simple N forces the condition to become false, and the program gracefully exits the loop.
All right, before we completely wrap up this explainer, I really want to leave you with a puzzle just to test your newly built programming logic. So ask yourself, does a while loop test its condition before or after it executes the code inside it? Think carefully, because if you get it wrong, your program might just run forever. Think closely about the exact sequence of events we just covered. Keep building, keep coding, and I will see you next time.